Good morning, everyone. Today we'll start with the chapter polymers of class 12. So, polymers are high molecular mass substances consisting of a large number of repeating structural units that are called monomers. As polymers are single giant molecules, that is, a big molecules, these are also called macromolecules. So, polymers are basically the combination of some repeating units. Those repeating units are called monomers. So, monomers, as you can see in the figure, let's suppose this sphere is orange sphere is a monomer. So, if two such monomers combine, then they will form a dimer. If three will combine, then they will form a trimer. If four will combine, a tetramer will be formed. And if so many like this dot dot dot, so many are combined, then it forms a polymer. That means n number of this will combine to give a structure which is considered as a polymer. So what is a monomer? The simple molecules which combine to form polymers are called monomers. So how these combine? The process where when these monomers combine is called polymerization. The process of formation of polymers from respective monomers is called polymerization. Okay. So classification of polymers. Polymers can be classified in four categories based on the source of availability, like they are present in the nature or they are synthesized by man-made or what. So based on the source of availability, we can classify polymers. Another category is based on the structure of polymers, like polymers are linear or cross-linked or depending upon how the monomers are attached. The third category is based on the mode of polymerization. This includes the mechanism how monomers join to form polymers. And the last one is the depending upon the molecular forces. Depending upon the intermolecular forces between the monomers, there is another category. So, coming to the first category, based on the source of availability, polymers can be natural, that is, they are coming from the nature. For example, the plants are synthesizing cellulose, or you can see cotton. No, cotton we are getting from nature, so that is a natural polymer. Synthetic polymers are those which are synthesized by man, and semi-synthetic polymers are basically that they have properties in between natural and synthetic polymers. We'll discuss these in detail. Coming to the second category, that is based on the structure of polymers, that is how monomers are attached. If the monomers are attached in a linear fashion, that will form a linear polymers. If they are attached in branched fashion, there will be a branched chain polymer. And if there is a cross linking and so much cross linking between the polymers, then it will be called as cross linked or network polymer. The third category that we discuss is the mode of polymerization. So it basically includes the method how monomers join and form polymers. So the addition polymers are those where monomers add simply and they generate polymer, and the other one is condensation polymer where the two monomers are attaching to generate another unit, one single unit, but along with that some small molecule will be released, that is a condensation polymer. And the fourth category, that is based on molecular forces. So based on the molecular forces, the classification could be elastomers, fiber, thermoplastic polymers, or thermostatic polymers. We'll discuss these in detail. So starting with the each category first, starting with the based on source of availability. So based on the source of availability, the first of the example is natural polymers. These are the polymers that are obtained from the nature, mostly plants. Animals get these polymers, like plants generate cotton and other natural polymers like cellulose and starch. Starch you see, that is also a polymer. And animals we see, silk is generated by a silkworm. So that is another example. Synthetic polymers are those polymers which are prepared in the laboratory. That means man is making that. Example, Teflon, you can see in the figure as well. Synthetic rubber, plastic, PVC pipes, these are all example of synthetic polymers. Semi-synthetic polymers are derived from natural occurring polymers but by carrying out chemical modification. These are basically the raw material is derived from the nature and somewhat it is chemically modified to generate a better quality of polymer. So that is called a semi-synthetic polymer. Example includes rayon that we use in our clothes, which makes the durable. Like cotton clothes are not that durable, but rayon ones are more durable. Cellulose nitrate, etc. These are the examples. Coming to the second category, the classification of polymers based on the structure of polymers. So based on the structure of polymers, as I said, if the monomers are joined in a linear fashion, that forms a linear polymer. If the monomers are joined like branch fashion, from here a branch started and from there it again formed a monomer kind of structure. From here one again branch started and this kind of structure is formed. So branching is there between the monomers structure, that is form a branched polymer. Cross-linked polymer is that the branches are too much cross-linked that they form a network. So in the first category, that is a linear polymer. Polymers here consist of long and straight chains. Example, high density polythene, PVC, polyvinyl chloride, etc. that we use in the pipes. And high density polythene is that we use poly bags in our daily use. We use the other one is the branched polymer. These polymers contains linear chains having some branches. Like in network polymer, as you can see, there are too many branches, but in case of branched polymer, there are some less branches. It includes low density polythene and cross-linked, or the last one is the cross-linked or network polymer. These are basically the polymers in which monomer units are cross-linked together to form 3D dimensional network polymer. Example, bakelite, melamine, etc. We'll discuss these in detail further, so don't worry. Um, the third category for the classification of polymers is the mode of polymerization. So, as I said before, there are two ways for polymerization, two methods. First one is the addition polymerization. Addition polymers are basically formed by a repeated addition of monomers with double or triple bonds. It is further classified into homopolymers. Homopolymers means polymers formed by the polymerization of single monomeric species. Example, polythene or polystyrene. Let me show you this one. That way you will understand better. So, for example, if you have a ethene, okay, let's suppose you have a ethene, hydrogen, CH2, CH2, no, ethene. So hydrogen is here, hydrogen is here. Okay, plus one more ethene molecule. Okay, so if these two ethene molecules are combined, okay, if these two ethene molecules combine, that means a dimer will be generated first. Like, how will this combine? Addition polymerization is these two will add. For example, the double bond will break homolytically over here and it will break homolytically over here. So the radical generated over here will couple with the radical generated over here. That means it will form a structure like this. Okay, this middle one is the new bond generated. The two radicals are free at the corner and the middle bond, this bond, is formed. So that's how if some or more molecules of ethene are present, they will couple in the similar fashion. So basically, it's similar kind of monomers. Like I took here ethene like A. I took A and A, they formed AA dimer. Okay, this is called homopolymer, homo addition polymer. Okay, but if some A combines with B, another type of monomer, then that will generate a copolymer. A combines with B, that will generate a copolymer. Okay, AB will be formed. Please excuse the background noise. Uh, so the other method, that is condensation polymerization method. So it basically includes the condensation. These polymers are basically formed by the repeated condensation reaction between two different bifunctional and trifunctional monomeric units with elimination of simple molecule. Basically, what is the difference between addition and condensation polymers? In case of addition, the monomers simply attach. There will be no loss of simple molecules. Like here you can see, in the case of condensation polymers, there will be elimination of some simple molecules. You can understand better with this slide. See, for example, ethene, as I said in the previous slide. See, if ethene are combined, there will be no loss of some simple molecules. Several molecules of ethene will combine to give this polyethene polymer, which and the process is addition polymerization. While in case of condensation polymerization, the condensation happens, and with as a result, the polymer there will be formation of bond between the two monomers, and along with that a small molecule will be released. Elimination of a simple molecule will be there. If it is a condensation polymerization, let's suppose one monomer is a diacid and another monomer is a diamine. So the diacid OH will do the condensation with the hydrogen of amine, and there will be release of H2O molecule along with the amide bond formation. Similarly, if the condensation happens between a diacid monomer and a diol monomer, there will be formation of an ester link, and ester bond will be formed, and there will be a release of water molecule and water molecule. So this is the difference between addition polymerization and condensation polymerization. Moving to the fourth category, there is the last one for the correct classification of polymers, which is the classification on the base of molecular forces. So first one category is the elastomers. These are the polymers chain that are held together by the weakest intermolecular force. These are the weakest one. Polymers like are rubber. Say rubber is so flexible, no, because of the polymer has so weak force of attraction between them, and like solids with elastic polymers. Example include Buna S, Buna N, neoprene, etc. We'll discuss the structures further in detail. The second example is fiber. Fibers are the polymers having strong intermolecular forces like hydrogen bonding. In elastomers, the bonding is weakest. But here, the have strong hydrogen bonding. Fibers are thread-forming solids which possess high tensile strength and high modulus. Since the bonding between the monomers is so strong, that gives the quality of high tensile strength and high modulus to the generated polymer. For example, it includes nylon 6, nylon 6,6 and polyesters. So basically, nylon 6 is also used in ropes. Why we use ropes for, because of their strength. So the nylon is used for that purpose. The third category is thermoplastic polymers. Thermoplastic polymers are held by intermolecular forces which are in between elastomers and fibers. In elastomers, the forces were weakest intermolecular forces, while in case of fiber, the forces are very strong. But thermoplastic polymers are those where the forces are in between that of elastomers and fibers, and we can say intermediate forces of attraction are there. And these polymers are capable of repeated softening on heating. Basically, these have this property. If you heat the polymer, it will it will soft, it will get softened. And if you keep it if you let it cool down, then it will start again hardening. For example, you have also seen that if polythene is melted, what happens if polythene is burned? Why it is burning? Basically, polythene is heated. So while it is heated, it is converted into black slurry, the black tar. So that's why when heated, it is liquidy. Okay, and when you let the that black stuff cool down, it again generates a hard. It gets hardened. So example includes polythene and polystyrene. The fourth category is thermosetting polymers. These are the polymers having cross-linked or heavily branched molecules, and which on heating undergo extensive cross-linking in modulus eventually and eventually undergo a permanent. For example, bakelite. So what you understand from here? Elastomers have a weakest intermolecular force. Fibers have strong intermolecular force. Thermoplastics are those which have intermediate force. And if you heat thermoplastics, they will soft and thin down. And if you let it cool, it will again harden. These are basically convertible. If they get soft, they get hardened. The property could be changed while heating and cooling. But thermosetting polymers are basically, if you heat it too much, then it will change its property, because there are so much branches in between that, because of which if you are heating, those branches will break, and eventually the cross linking between which on heating extensively, cross linking more cross linking will happen, and permanent changes will occur. Like in case of thermoplastic, the changes were temporary, they were convertible. But in case of thermosetting, the changes will be permanent because of the heating. Examples include bakelite, urea formaldehyde, resins, etc. So this is the figure where you can see in the case of thermosoftening or thermoplastic polymers. These are the tangled polymer chain. You can see no cross linking between the chains. Weak forces of attraction between the chains, but when you heat it, they become soft, and when you let it cool, it becomes hard. While in case of thermosetting, there are cross linking between the monomeric chains, and there is strong covalent cross-linking bond that does not break on heating. It remains hard only when it is heated. So let us discuss about the addition polymerization methods or mechanism, how addition polymerization occurs. I think we should discuss this topic in the next video only, otherwise the video will be too long. So we'll discuss the mechanism of addition polymerization and condensation polymerization, and some examples of these polymers and their monomers, and how they are formed in the later video. Thank you.